So hi guys, thank you for attending this session. So we'll have a webinar with Nicolas Oquet. Nicolas will introduce himself afterwards. Yeah, so I'm Christoph. I'm working with Computer Futures for over 3 years. I've been focusing on the Java market in Flanders and Brussels during the past 3 years. More recently focused as well on data markets. So that's why I'm cooperating with Nicolas to do this webinar so we can share some knowledge with our network. So some practical notes. There will be a Q&A afterwards. The talk will be about 35 to 40 minutes. So leave your questions still afterwards, and Nicola will be happy to answer them. And if there's not enough time, he will answer them in person via LinkedIn or any other media. And as well, the session will be recorded. So the recording will be made available as well afterwards. So I'll now give the floor to Nicolas to go deeper into the subject.
Hi, everybody. I'm first going to introduce myself a little bit. So I'm Nicholas. I'm a senior Java developer, currently working for Lightspeed. I've been developing since I was a kid, after seeing the movie The Matrix. Don't ask me why, I just found it very inspiring. Since then, I've been busy with technology, with programming language, etc., etc. And lately, I've been taking an interest in coaching people, as I see that there's a real need for that, right? People are getting more and more interested in technology, but they don't always find the right guidance. So this is also why I'm doing this webinar. I suggest we get started right away. So let me share my screen. Where is it? Where is it? It's over here. Oh boy. Can everybody see my screen, by the way? All right, so you should be seeing my slides now. Zoom isn't being supportive at this moment. Okay. So welcome to my webinar. This webinar is about going from problem to class design. And since we only have 40 minutes, it's going to be a beginner's guide. So in this webinar, what are we going to do? We are going to look into why we need a design, right? And then we are going to tackle a problem case swiftly, however, right? And at the end of the webinar, there's going to be a very short recap of what has been going on for the past 40 minutes. Something to remember this webinar by. Okay, so why do we need a design to solve a problem? And for the record, when I say a problem, I do mean a business problem, right? There's no code in the world that will solve your personal problems. So, but why do we need a class design? Why can't we just fix business problems with one class? Well, let's find out with a little story. This is John, right? John is a software developer, right? And this is John's latest work. It's his latest project for his latest and also for his only customer. John solved the business problem of his customer with one single class. This piece of art is like 60,000 lines of code, which is amazing. Really, John, you are so talented. Right, so after hours and hours and hours of coding, John decides to run his application for the very first time. So John starts up his application and boom, it doesn't work. So somewhere in that huge pile of code, there's a bug. There's like 60,000 lines of code in there. And Jesus, sometimes I have trouble finding a bug in only 50 lines of code. So here's a question for you guys. How much time do you think John will spend in order to find this bug? By the way, this is a rhetorical question. You don't need to answer it right now. Just something to think about. So yeah, this means bug fixing. John digs into his code, and after some time, he thinks he has found the problem. And so he applies a fix and he runs his application again. And boom, the bug is still there. Oh dear Lord. So John decides to gracefully shut down his application, but he notices that his application doesn't shut down gracefully anymore. So that means that the fix he made actually broke other functionality. How happy do you think John is at this moment, right? And another question, how do you really know that your application is doing what it's supposed to be doing? Now, at this point, John has lost so much time already. It's time to call in reinforcements. He needs help at this point. So meet Jane. Jane is also a developer and she's John's best friend. She is an excellent problem solver. So John and Jane decide to tackle these problems together and they decide to split up the work. John is going to find out what the original bug is and Jane needs to figure out why the additional functionality broke. However, very soon Jane is getting frustrated and she says to John, like, hey John, this code is so complex and so hard to understand. I have no idea where I need to start looking for that broken functionality. So how much time do you think Jane will need before she can actually start helping out? How much time will she invest before she can start helping out John? All right, the joys of teamwork. So John and Jane are independently working together. So they each try to solve their own problems. However, the frustration levels are skyrocketing. It seems like they are constantly affecting each other's work. Like there are merging problems. John deletes accidentally some new code of Jane. Jane doesn't seem to understand what the new code of John is doing. In short, it's a mess. So how helpful do you think it is to work together like that? Then John's phone rings. It's his future customer, right? And this guy says like, hey John, how are you doing? I hope you're well. Do you remember that functionality we spoke of last week? Yeah. Well, I changed my mind and I would like you to change that functionality. But for sure, you need to leave the rest as it is. Could you please manage doing that until next week? And obviously, John didn't take it well, right? So this little story, obviously it is fictional, right? It's pure fiction. This is not an autobiographical story, by the way. I was not John in a previous life. It's pure fiction, pure made up. However, some parts of this story do feel familiar, right? There are some parts, there are some lessons actually that we can learn from this story about how software should be, maybe about why we need software design. Sorry. So which lessons could we learn from this? Well, from this story, we can learn that software should be testable, right? You need to be able to test parts of your application in isolation so that you know that your software is doing what it's supposed to be doing. Software should also tackle complexity instead of adding complexity to the problem. So in other words, your code needs to be understandable and easy to navigate. When you've broken up your code into different parts, it's so much easier, it's so much easier to tackle the complexity, to manage the complexity. When you have different parts in your code, I'm sorry, I seem to have a hic from my last cup of coffee. When your application is broken down into multiple parts, so when you have a real software design and each part has its own function, it's so much easier when there is a bug for another developer to find the origin of the bug, right? And then lastly, the last lesson that we could draw from this story is that software should enable teamwork. It's so much easier if you have multiple parts, if you have multiple code units or classes for different people to work on the same code base. It's as easy as that. Now, all of these reasons and all of these lessons, they actually have an overarching reason. There's like a higher purpose for doing this. Why does your code needs to be testable? For sure, you need to know that your code is doing what it's supposed to be doing. However, if you have tests, These tests give you confidence that when your code is changed, that it's still working, right? Why do you want your code to be easy to understand? Sure, you can manage complexity easier. Sure, you can find bugs easier, but also understandable code makes it so much easier to change the code. And why you want teamwork? Yeah, it's indeed excellent if you can work with multiple different people and the same code base. However, together you can change faster, right? Now, to me, this is one of the most important aspects of software design, and that is software design, or your software or your code, it needs to be able to deal with change fast. Now, that doesn't mean that your code needs to be able to change fast, because changing code fast, that's easy. You just open up your IDE, you start typing, and boom, you've changed your code. That's not the point, right? So testability, understandability, being able to work together on a code base, these are like code qualities that enable change. However, a code base or code can also have qualities that cripple change. One of the most known qualities that cripple change is actually coupling. Coupled code can cause the ripple effect. What is the ripple effect? That is when you have to change a certain class, and after you changed it, you notice that actually you also need to change other classes. And it goes on and on and on throughout your code base, and it makes you lose time. Coupled code can also cause possible side effects and bugs. And it is even so that your tests might not always pick up these bugs or pick up these side effects. The more your code is coupled, the harder it is to change, right? And in order to illustrate that, let's follow along on the following diagram. Now, the arrows on this diagram, they define the following relationship: is used by. So in other words, this coupled class is used by this class and is also being used by these unrelated dependent classes. And this class here is being used by this class, right? Now imagine that you need to change something in this code base, right? And you expect the following classes to change, right? This dependent class and this coupled class. Because everything is so coupled, there is actually a high chance that at least any of the following classes will also have to change, or at least will be affected by the change that you need to do. Now you might say, how bad is that? Just if it's one class, if it's a simple fix, just fix it and be done with it. But then you're missing the point, because when you need to fix this, you're spending time on it. You're actually spending time on fixing a class or fixing code which you weren't supposed to fix, which you weren't supposed to touch actually. And let's not forget about the tests, because the tests, you can spend a lot of time fixing the tests as well. Now, I also need to say that not all coupling is bad, right? It's natural for classes to work together. So a natural coupling, that's okay, that's fine. It's more how these classes are coupled and the level of coupling that will impact how hard it becomes to change the code base. All right, I know I'm going pretty fast, but now that you understand the basics of what a design should do and what it actually is and what's important when designing a system, I say let's just go from problem to class design. So what am I going to do? I'm going to walk you through a case as good as I can, right? I'm going to walk you through a problem case, and we are going to analyze this problem. We are going to use one of the most simplest analyzing tools and techniques that we have, which is actually asking questions. And with the answers of these questions, we are going to break down this problem into sub-problems and smaller problems, and eventually into classes. In the meantime, I will be explaining my thoughts and also the reasons why we should do this. Now, I must also say that there's a lot of ways of doing this, but this is just my personal approach. This is how I prefer to do it, okay? Then I suggest that we just dig right into it. And imagine that we have the following problem. Okay, so this is a wall of text, but no fear, I'm going to explain it. So imagine that there's a couple of people and they want a system to upload and import large CSV data files. These files, they are just data from another company and they want to migrate, okay? And so these files, the data of these files needs to be inserted into our own database system. These files also need to be validated line by line, checked for errors. If there are no errors, then this file needs to be imported automatically. And at any time, one of the business people from our own company needs to be able to check the status of the import. Okay, how do we start? What do I usually do? When I get a problem like this, doesn't matter where I am, if I'm at my desk at the office or if I'm at my home office, I like to make myself comfortable, something like this. And I like to think about this problem, right? What I try to do is I try to get a grip, a high-level overview of what it exactly is that this piece of software that I'm going to write needs to do. I try to uncover all of the things that a user of my application wants to do, all of the functionalities. I guess with this problem that it's actually rather simple to do, right? So we want a customer to be able to upload a data file. We want a customer to be able to validate a data file. At any point of time, a customer or a user of the system needs to be able to check the status of an import. And of course, the application needs to be able to import the data file as well, right? All right, cool. Seems like we've nailed this. We know what we're supposed to do. Let's get the coding started. Yeah. No, actually, starting to code right now would be a big mistake. Why would it be a mistake? You only have a high-level overview of what you're supposed to be doing, right? When you're coding, you're going to take design decisions, and you're going to take these decisions with the limited information that you have. And eventually, these decisions will turn out to be a bad thing. So there's still so many questions and still so many unknowns about this problem. For example, what needs to happen when the upload of the data file goes wrong? Where do we need to store this data file? What errors do we need to validate? What needs to happen when this file has errors? How are we going to notify these users? Who are these users? Where are we going to store everything? I mean, it's very easy to get overwhelmed, right? The actual problem that you're having is that you don't know where to start. When I first started out as a junior developer, I had the exact same problem. You are very tempted to just start coding anyway and figure it out on the go. But like I said, this would be a real problem. This would cause problems in the long end. So where do you start? What do you actually do at this moment? It's very simple. First, stay calm, because there's actually only one question that you need to solve right now. And that question is, which part of that high-level overview that you just made will bring the most value? And you start analyzing that one. So the part that brings the most value, who is going to answer that question when you ask this question? Who will bring the answer? Who do you need to ask this question to? Well, actually, your stakeholders. They should know the answer to this question. Who are your stakeholders? Well, stakeholders are the people that have a real interest in the success of your application. For example, your future users, your future customers, people who helped finance this project, people who put money in the project. Those are your stakeholders, and they should be able to answer any question that you have. So when we asked the stakeholders what part would be the most valuable right now, this is what imagine that this is what they're saying. So they're saying that there's already a legacy system for inserting data, right? So we don't need to take care of that right now. The business analysts, they manually store files somewhere on an FTP server. So at the moment, we don't really need to care about uploading and storing data files. However, they say they don't have any validation yet. So when they are inserting data and it fails after 2 hours, they need to do everything over again. Well, that's very interesting to us, right? So this means that we could focus on validating a data file. That means that we only need to worry about validation. All of the other questions and all of the other unknowns of the other parts, they don't matter now. We can solely focus on validating a data file. And while there is still a lot of questions and still a lot of things to discover, it's way less overwhelming to start with this one. Okay, so now it becomes clear that we need to dig deeper into this validation step. And how are we going to do that? We're going to do that by asking questions. Now, these are the questions that popped up into my head immediately when I had this problem. There's plenty more questions that you could ask, right? I just want you to understand that asking questions is the way to go. I want you to understand that what I'm trying to do is I try to understand what is going on. I try to uncover. There's something wrong with Zoom, by the way. It sometimes takes sometimes takes a long time before I see anything on my screen, which makes me click too fast or click back, actually. So I'm sorry for that. So to recap, I try to understand what is going on. I try to understand what the problem really is. And this is really important. I try to reveal what needs to happen step by step. So the questions that I have is, what steps do we need to take in order to validate a file? What are the errors that we are looking for? What needs to happen when the file contains errors, and what needs to happen when the file doesn't contain any errors? Stuff like that. So the answers, I'm not going to go over all of the answers. I'm just going to highlight a few. Like, for example, what errors are we looking for when we are validating? This is important for you to know in order to be able to follow along with this webinar, right? So the errors that we are looking for, it turns out that we need to check the length of these CSV files, of these CSV lines. So some of these lines have more data, some are missing some data, so we need to check for that. Also, there seems to be values in these lines that are unknown to our system. So we need to translate these before we insert the data, otherwise we get errors and we need to restart again. What if the file has errors? Well, if the file has errors, it appears to be that business analysts need to be notified. And also these errors need to be stored in a database, and the file needs to be flagged as invalid so that an analyst can deal later with it. And if a file has no errors, we actually already knew the answer to this. If a file doesn't have any errors, you can set it ready for processing and importation. So we need to figure out how this legacy import system works. That's it. All right. What I like to do with the information that I've gathered is visualize it. When I visualize stuff, it gives me a bigger picture of what is actually going on. Now, for this validation, or for this data file validation, it's clear that this is a process. So what I did was I drew out the flow of this process, right? If you want, you can use UML for doing that. I just prefer to draw boxes. The thing is, it just needs to be as simple as possible so that any other person involved in the project or involved into the development of this application can understand what is going on. All right, so let's go over what we have learned. First, we have learned that in order to validate a data file, we need to get the file from storage. Then we need to check each line if the length is okay, and we also need to check the values of each line. If there are errors, we need to keep track of these errors. And at the end of the file, we have a decision to make. If there are errors, then we need to save it to the database and notify business analysts. If there aren't any errors, then you can set this up for processing immediately. Now, after I have visualized what I've learned, again, and I do this regularly, really, I like to sit comfortable again and think about the problem, you know, something like this. And in this case, I'm thinking like, how interesting. Because there is something very interesting going on with all this. And I've hinted at it with the difference in color, right? It seems to be that there is a difference in level of detail emerging. It seems like these blue boxes, they tell us a story with just a bit more details. Or let me put that differently. It's like these blue boxes, they are a sub-problem or a sub-process of the validation process, and they have their own steps. Now that is very interesting. So here I have redrawn this schema or this diagram to make the difference in level of detail a bit more obvious, right? So the orange boxes, they seem to tell us what needs to be done. However, they do not give us any details on how to do it. That's what the blue boxes are doing. It's as if these blue boxes, they form a layer of details, a complete new layer of details. And actually, I think personally that these layers of details, they make a great reason, well, they are a great reason or a good reason for making classes or packages. Now, if we look at these orange boxes again, we notice that it's not only for the file validation step, which we see right here, that we have these layers of details. When we look at these boxes, we see that there are still other unknowns and questions in there, right? There might be other sub-problems to be discovered. For example, setting up a file for processing. What exactly do we need to do there? So apparently we need to move it to an import directory. It's a legacy system, right? We're still talking directories. They don't know about Amazon yet. We need to update the status and we need to notify business analysts. This could be a good reason for another class. What I'm trying to say is that when you have this overview, when you know what steps you need to take in order to solve something, look for the details, because that's where the interesting part is when it's about making classes. So making classes based on these layers of details, why would this be a good idea to do that? I see three good reasons for doing that. First reason is that you want to group together what belongs together. Some of you might have heard this already, because this is just basic cohesion, actually. When you group together what belongs together, you can isolate change. Now, how does this work? Well, these layers of details, they actually are a collection of details about something very specific, right? In our example, they were the details specific to validating one file line by line. So that means that these details, they belong together. And because they belong together, they will most likely change together. Now, if you put all of these details together in one file, you can isolate that change and make sure that it doesn't spread out to other layers of details. And by doing that, you actually enable change in your code base, or you make it easier for your code base to deal with change. Now, a second reason why this would be a good idea is that you, as a designer of a class or as a designer or developer of a code base, you have the opportunity to create a flow of code that's very understandable. I know it's a bit vague what I'm saying now, but there's an example coming up. So you could use techniques like encapsulation and good naming conventions to make something that's really pleasant to read. When you do that, you actually tackle complexity. And we know already that when you tackle complexity, you enable change in your code base. A third reason for making classes based on these layers of details is that you will create small classes which have only one purpose. Now, what happens when you have small classes is that you, I would say, almost say automatically, you create testable code because these small classes are very easy to test. And classes that have one single purpose, they tackle the complexity or they help manage the complexity of the problem, right? It's a lot easier to navigate when you have small classes which only have one purpose. And by doing so, again, you enable change in your code base. So based on all of this, for this particular part, right, validating a data file, I would decide to make two different classes. The first class would be named the file validation class, and a second class would be called the validation process class. All right, this file validation class, it appears that I want to create a class out of the high-level overview of file validation. Why would I do that? Well, firstly, this class, like I said before, it contains all of the orange boxes, right? This class is going to tell me what needs to happen when I validate a data file. It contains almost no details on how to do that. So you might say that this class is somewhat of an abstraction, right? And because it's an abstraction, because it contains very few details, it's very unlikely to change a lot. And that on its own is a great reason to create a class. So at one hand, you want to create classes out of details that will change a lot or change together. And at the other side, like this example, you want to create classes that are unlikely to change, abstractions. I call this kind of class a flow controller or an orchestrator. Now, why do I do that? It's because an orchestrator or a controller, it knows what needs to happen, but it doesn't know how. And so it delegates the how to other classes. You could see these details of how to do things as concerns. And you want to separate these concerns into different classes. And then you want to delegate to those classes. Now, when you do this correctly and when you do this well, and you use techniques such as encapsulation and good naming conventions, which is really important, you can end up with something like this. Now, this is a bit of a Java related example, but I can assure you that it works just as fine in PHP or in .NET or even Python, right? So this is actually as easy as it gets. This reads like a book. This is, by the way, almost the entire file validation class. It has one method, which is called validate file. And you can read each step of what needs to happen to validate a file right here. And as you can see, I made the assumption that I was going to create other classes to delegate whatever needs to happen. For example, I might have a file getter class which will get me the file to validate. You can see that I've put a question mark next to it because I might also not do that. Oh, you say, what are you saying? This is confusing, but hear me out. If it turns out that getting a file is very easy to do, like for example, I can do it in one line of code or maybe 2 lines of code, then I might be tempted to just create a private method for it. And you don't have to create a separate class for doing this, right? It's the same thing for this import component. If setting a data file ready for import, if it's really easy to do, just create like a private method for it. When it comes down to separating concerns from your class, the things that you need to keep in mind is how complex is it and how much details it is. So then you have to use your common sense in order to decide if you're going to extract these details or not, right? Okay, then the following class is the validation process class, right? So I decided to create a class out of this sub-process. Now, why did I do that? This class is going to tell us how the validation is done. right? It's going to tell us how a data file is being validated line by line. Now, obviously, this class will contain more details, and thus this class is more likely to change than the previous class. And that's fine, because we want to isolate any possible changes to the validation process right into this class. That's very important to understand. Now, when we look at these blue boxes, we realize that there's actually still some questions to be asked and some unknowns, right? For example, how do you check the length of these lines? What steps do you need to take in order to do that? And it's the same thing for checking for unknown values. How do you do that? What steps do you need to take? So it's actually possible, when we continue with this process, that we extract these details again in another class, and that this validation process class, and that this validation process class actually also becomes an abstraction, and that's totally fine. So after doing this entire exercise, you will eventually end up with a design. You will eventually end up with something that looks like this. Now, this is by far a complete diagram, right? I haven't put every possible class in here because it just doesn't fit my slides. But when you look at this diagram, it should become clear that each function, each functionality, or let me put it this way, each thing that a user wants to do with your application has its own set of classes, right? This is very important to understand. This is like the point of this entire webinar. So I'm going to say it again. Each functionality, each thing that a user wants to do has its own set of classes. And you can turn this around. It means that each class, each thing in these orange boxes should only serve one functionality. It should only serve one feature. If you do it like that, it becomes more easy in dealing with change because your functionality is decoupled. I would like to explain this more, but we only have 30 to 40 minutes. So I hope the message reaches you guys, right? But this is the main gist. I also want to say that there's no perfect design. For sure, there are going to be objects or classes that will be shared between functionalities, that will be shared between functions, right? For example, everything in gray boxes. This is like a REST controller from Spring right here, where you have an endpoint to validate a data file, where you have an endpoint to upload a data file. You will also have like a common error handler, and you will most likely also have a common entity, right? And that's fine. There is no perfect design. This is the guy who searched for the perfect design, and he failed miserably. It doesn't exist. There's only a design that does well with change, and there are designs that don't do well with change. And then you have designs that do better with change or do worse with change, but there's no perfect design. Now, a small recap. So what exactly happened here in the last 30 minutes? What did we do? What's the workflow? What did I try to teach you guys? So the first thing that you want to do when you have a business problem, when you have a project, when you want to start an application or writing an application, is you want to have a high-level functional overview. You ask yourself the following question: what do I want my users to be able to do? When you have that, you split it up into logical steps. Then you try to discover the details of each of these steps. And then you split up these details into logical steps again. And you keep on repeating this process until the complexity can be managed by either a class or a method. And that's basically it. This was my webinar. Thanks for attending. I realize that there's probably a lot of questions and maybe things that are unclear. So hook me up.
So any of you guys got any questions for Nicolas concerning his talk?
Oh, by the way, you can always add me on LinkedIn if you have burning questions or if you have very custom questions. I would be happy to help you guys out, really. So everything was clear, crystal clear. Well, actually, that's awesome. That means that I did a good job, right?
Edgardo agreeing with everything. No questions from Jonathan or Robert, Mamta, Lisbeth, perhaps?
Not immediately, but I might later, so I will add us to LinkedIn.
Yeah, sure. Please add me anytime if you have questions. I would be happy to answer them. This is what I like to be doing, by the way. I've seen too many developers, doesn't always have to be junior developers, by the way, who, you know, don't do that well with design. So just ask.